My name is Amar. I'm a graduate trainee engineer at WMG, and I work with autonomous vehicles. So essentially vehicles that can drive themselves. And today I'm going to talk to you about how we can teach our cars to sense our world. The roads that we have now are rather dangerous places. There's approximately 153,000 casualties in road traffic accidents in the UK. Around 1.35 million people's lives are cut short every year. Now, to put this into context, that's approximately 15 full aircraft of 200 people disappearing each day. Now, if this happened in the aviation industry, this would raise some alarm bells and would likely result in all the planes around the world being grounded. So why is it different here? We also spend around 3 full working weeks in traffic. I'm sure many of us would rather be on holiday or at home in this time. And from an environmental point of view, road traffic accounts for about 25% of the total carbon dioxide emissions that the UK has. This isn't all. We also have the problem of speeding. An average increase in speed directly relates to both the likelihood of a crash and the severity of that crash. And this also isn't helped by drivers using their mobile phones whilst driving. We all know how dangerous this can be. Drivers that use their phones are approximately 4 times more likely to be involved in a crash than drivers not using a mobile phone. So what links this all? It's us. 90% of road traffic collisions are caused by human error. The previous issues also sum up how inefficiently we drive, whether it's speeding up between lights to make a green or all leaving work at the same time. Both aren't great for traffic and the environment, but autonomy can solve these problems. Here on the screen, we have 3 different cars, each with a different group of people in them. In one, you've got people working. In another, you've got people watching TV or playing games. And in another, you've got people literally doing nothing, just relaxing. There's also other benefits. So 1 in 5 adults in the UK is registered with a disability. Now imagine we can give them independence with autonomous vehicles. They don't have to think twice about asking someone for a lift or think twice about simply getting into a car. You've also got the reduced strain on our emergency services. If there aren't any road traffic accidents, the police and the ambulance service won't need to go to them. As I mentioned before, you've got the entertainment benefits. People can game or watch TV in their cars. People can eat and drink safely. There'll be a massive increase in productivity and also the mindfulness benefits. So people have time to themselves without having to road rage or think about other people on the road. Now, you're probably thinking that this is a huge leap in technology and it's going to take years and years to implement, but you'll be surprised at what we have already. We already have computers that can control our brakes with anti-lock braking systems. We've also got adaptive cruise control, so you can drive on motorways without having to touch the pedals, and this massively increases the comfort of any drive. You've got blind spot monitoring, so your car can tell you if someone's in your blind spot. Now, these are individual elements, but we've also got systems that bring all of these together. So we've already got cars that can park themselves. So what's stopping us achieving full autonomy? I think it's trust. We're worried about the change that the technology will bring to our day-to-day lives, which is normal when any new technology is introduced. But we need to understand the benefits that this will have, as I previously mentioned, and the way that it will change our day-to-day lives. So this trust could lead to a change in ownership. Instead of having to buy a car for a large amount of money, you might pay a small subscription fee, just like your Netflix, to share a car with those around you, and also be able to summon a car like you would a taxi. You wouldn't have to do the mundane things that we all dread. You wouldn't have to spend half an hour looking for parking before you go shopping. Your car will simply be able to drop you off and park itself. Now, how many of us could park like that in the top right? And imagine if your car was parked in the middle, it just wouldn't work. But autonomy can achieve this. We've also got the last mile principle. So essentially, your car could drop you off down the road from where you work or where you go to school, and you'll be able to jump in a pod or an electric scooter to take you to your doorstep. So what are we doing at WMG? We've got a car that you'll recognize just with a few added things. We're trying to bridge the gap between what we have at the moment and what we want to achieve. We're able to add and remove sensors depending on how technology develops, and we know how fast that is. And we can also add and remove sensors depending on how the needs of autonomy change. We're able to support smaller companies that don't have the resources to develop such a platform, so they can test small aspects of their work rather than having to build something like this. Now let's meet your driver. This is essentially where all the information is processed. So essentially the brains of the vehicle. Your vehicle will likely have something like this, but probably a lot smaller in the future. So you can see it's got a lot of computing power and networking capability, so it can talk to other cars and infrastructure. Now, where is all this information gathered? This is where our sensors come in. So you can see we've got camera. So these essentially replace your eyes. This is what can see around the car. Now, many of us are sat facing a screen right now. If we sit forward and think, how far can we actually see around us? Where is your blind spot? It's probably not very far. But these cameras alleviate that problem. They can see fully around the car, 360 degrees. LiDAR can do the same. LiDAR is your eyes being able to see through fog and snow. We've got other sensors on the vehicle as well. We've got ultrasound. So this is what beeps when you're reversing or parking. We've also got radar, which is similar to LiDAR, but uses different technology. Now, what our cars can see is astounding. We can see about a football pitch away and recognize something clearly. Now, how many of us can actually do that? This is what we see when we're driving on the roads. This is a roundabout at the University of Warwick. So we can see the junctions, we'll likely see other cars and people. But this is what our car sees. This is individual points built into a map to essentially build a point cloud. Each of these points has a coordinate and can be clustered together, so grouped together to make up objects that can be recognized by the vehicle. Now, let's put this into a little bit more context. You can see here it's a video on the screen. So on the left, you have a camera, and on the right, you have what a LiDAR sees. You can see that the vehicle is recognizing objects and placing boxes around them to label what they are, just like we'd do. We'd know if there was a car or pedestrian there, and because of that, we'd be able to react in a certain way. This is what we can get our car to do. Now, all of these sensors and the work being done will be able to create safer roads for everyone. We want to reduce traffic with networking. We want to reduce the number of collisions on our roads with what we're doing. And we also want people to not have to think twice about getting into their cars with a massive leap in accessibility. Who knows what the potential of all of this is? Maybe you won't need to ask someone for a lift, and you might not need to learn how to drive. Thank you.